This is a second video over section 7.9, triple integrals with spherical coordinates. And so we're going to integrate over the unit sphere of the square root of x squared plus y squared plus z squared dv. And this would be fairly challenging if we were going to use rectangular coordinates. Now, if you're integrating over a rectangular prism, then using rectangular coordinates is the best choice. If you're going to integrate over a cylinder, then using cylindrical coordinates is the best choice. But since we're integrating over the unit sphere, we're integrating over a sphere, spherical coordinates are the best choice. And so the unit sphere, rho goes from 0 to 1, theta goes from 0 to 2 pi, and phi goes from 0 to pi. So these are our limits of integration for the unit sphere. X squared plus y squared plus z squared is rho squared. So we simply have the square root of rho squared, which is rho, because rho is between 0 and 1. And then we have our rho squared sine phi, d rho, d theta, d phi. Simplify it. Find an antiderivative with respect to rho. That's not so difficult. We just pretend that theta and phi are constants. So we have 1/4 rho to the 4th. Substitute 1, substitute 0, subtract. So we have 1/4 sine phi, d theta, d phi. Next we integrate with respect to theta, and we're just treating phi like a constant. So we just have 1/4 theta sine phi. The theta limits of integration, 0 to 2 pi. So substitute 2 pi, substitute 0, and subtract. So we have the integral from 0 to pi of pi over 2 sine phi d phi. An antiderivative of sine phi is negative cosine phi. We have our limits of integration. Substitute pi, substitute 0, subtract.